We are here again in the chemistry class. The topic of the day is carbon. The following are the objectives for the day. Number 1, carbon, an element in the periodic table. Number 2, carbon in nature. Number 3, isotopes of carbon. And then we have a short activity. Carbon in the periodic table. Carbon is one of the 118 elements in the periodic table. It is a non-metal. Let's take a short activity. Locate carbon in the copy of periodic table you have. What group and period is it? How many electrons does it have? What is its atomic mass? Carbon is found in group 4 and period 2 of the periodic table. It has an atomic number of 6 and an atomic mass of 12. Carbon in nature. A lot of natural substances, living and non-living, contain carbon. Here are a few examples. 1, wood and its products. Some products of wood are as follows: textiles, the clothes you wear; paper, used for production of stationeries; and furniture. Number 2, food substances. These include carbohydrates, proteins, fats and oils, vitamins. Number 3, petroleum and its products, such as kerosene, diesel, bitumen, asphalt, lubricating oil. Number 4, natural gas. 5, coal. 6, rubber latex from rubber tree and its products. 7, soot, that is the black powder produced from the exhaust of vehicles and machines. 8, bones, teeth, and shells of living organisms. And 9, limestone and marble. These are just some natural substances containing carbon. The study of naturally occurring compounds of carbon is called organic chemistry. However, carbon oxides and sulfides, trioxocarbonates 4 and hydrogen trioxocarbonates 4 compounds are studied under inorganic chemistry. Isotopes of carbon. Isotopes are atoms of the same element having the same atomic number but different atomic masses due to difference in the number of neutrons. Common isotopes of carbon are carbon-12, carbon-13, carbon-14, and fullerene. Fullerene is a newly discovered isotope of carbon and it's still under study. The number stated in each of the isotopes above mentioned refers to their atomic masses. They all have an atomic number of 6. Let's take the classwork. List 8 elements that exhibit isotopy. List 8 elements that exhibit isotopy. You must have done this earlier on in the session. The answer is hydrogen, sulfur, phosphorus, chlorine, carbon, potassium, and mercury. Hydrogen, sulfur, phosphorus, chlorine, carbon, potassium, and mercury. Now take down these questions as your assignment before we time out. Find out the uses of each of the isotopes of carbon treated in this lesson. Find out the uses of each of the isotopes of carbon treated in this lesson. Number 2, write down at least 2 of the isotopes of the elements mentioned in the classwork. Write down at least 2 of the isotopes of the elements mentioned in the classwork. We'll come back later. Welcome back from the short break. In this segment, we shall be talking about the allotropes of carbon. Allotropes of carbon. Carbon exists in various forms in the same physical state. The ability of an element to exist in various forms in the same physical state is called allotropy. The allotropes of carbon can be classified into two: A, non-crystalline allotropes, B, crystalline allotropes. Non-crystalline allotropes of carbon. These are actually not considered to be true allotropes of carbon. They include A, charcoal, B, coke, and C, gas carbon. Charcoal. There are three types of charcoal. Number 1, wood charcoal. 2, animal charcoal. And 3, sugar charcoal. Wood charcoal is formed by burning wood in limited supply of air or limited supply of oxygen. It is used in gas masks to absorb poisonous gases. Animal charcoal is formed by burning animal wastes and bones in limited amounts of air. It is used to decolorize crude sugar and as a disinfectant. Sugar charcoal is formed by dehydrating sugar with concentrated tetraoxosulfate 6 acid. It can also be prepared by heating sugar cane or glucose in the absence of air. It is used to prepare artificial diamonds and as a reducing agent in the extraction of metals. Now, the second non-crystalline allotrope, coke. This does not refer to the carbonated drink we take. Coke in chemistry is produced when coal is heated in limited amounts of air to a very high temperature of about 1,300 degrees centigrade. It is used as fuel, a reducing agent in the extraction of iron from its ore, and in the manufacture of graphite, calcium carbide, and carbon 4 sulfide. The third non-crystalline allotrope, gas carbon. It is obtained by burning the liquid fractions of crude oil or coal in limited amounts of air. It is a good conductor of heat and electricity. It is used to power some lamps. Now let's talk about crystalline allotropes of carbon. These are A, graphite, and B, diamond. They are the true allotropes of carbon. We will time out here and come back again. Welcome back from the short break, and we are starting with the properties of graphite. Properties of graphite. Number 1, it is a black, opaque solid with a metallic luster. 2, it is relatively inert, that is, it is unreactive. 3, it is one of the softest substances and marks paper. Number 4, it has mobile electrons in its structure and so is a good conductor of electricity. 5, it can withstand high temperature. And 6, it has a density of 2.3 grams per cm cubed. Let's consider the uses of graphite. 1, it is mixed with clay as a soft substance to produce lead pencil, a common writing material. 2, it is used as an electrode in batteries and in electrolysis because it's a good conductor of electricity. 3, It is used to line crucibles used for making high-grade steel and alloys. Number 4, it is used as a solid lubricant in engines and sometimes mixed with oil to produce high-temperature lubricants for machines. Properties of diamond. 1. It is a colorless, transparent solid. It sparkles when cut or polished. Number 2. It is the hardest known substance. 3. It is very reactive. 4. It is a non-conductor of electricity. 5. It has a density of 3.5 grams per cm cubed. Uses of diamond. It is used to make cutting, boring, and drilling tools because it is the hardest known natural substance. Number 2, it is used to make jewelries. Diamond jewelries are very expensive. Let's consider the structure of graphite and diamond. Structure of graphite and diamond. Graphite has a sheet-like hexagonal structure. These hexagons are arranged in sheets that are parallel to one another and can easily slide over each other. This property, together with the soft nature of graphite, is the reason why graphite is used as a solid lubricant. The carbon atoms in graphite are bonded in such a way that there are free, that is, mobile electrons. This is the reason why graphite is a good conductor of electricity. Diamond has an octahedral structure. The carbon atoms in it use up all their valence electrons in structure formation. As a result, diamond has no mobile electrons like graphite, and so it is a non-conductor of electricity. Now, write down this assignment to be done immediately after the lesson. Draw the structure of diamond and graphite. Draw the structure of diamond and graphite. Compare these two structures. Thank you for listening. God bless you.